Jonathon Freye. I am one of the members of the managing board for the Aero Club of Washington's Runway program, our program for emerging aviation professionals, and want to thank all of you for being here. We've got a great panel of experts with us today. Unfortunately, one of them, Brian Sherbicow from World Energy, is a bit under the weather today and not able to join us. But we've got three great folks from the industry that I'm really looking forward to having a discussion with. The administration and the Secretary of Transportation have made clear their desire to implement transportation and infrastructure policies that are sustainable and reduce greenhouse gas emissions. The aviation industry has made significant commitments to those goals, both the business aviation industry and the commercial side of the industry as well. Our experts today, I think, will help us to explore what progress we've made, what existing programs are out there, and to try to look ahead to what policy support the industry might need from the federal government and what the industry can do on its own. I'm going to launch right into the first question, but I would welcome the folks that are with us today to go ahead and send a chat to us. If you've got questions, we want to keep it informal, conversational. So we'll try to leave a few minutes for questions at the end, but if things come to mind as we're going through our discussion, I hope you'll feel comfortable to send us a chat. I'm actually going to open the first question up to either Kevin or Steve or Tom, whoever would like to jump in here. I'm hoping that we can start off this discussion today by framing out the industry's impact on global climate change. And I know that that's really open-ended. So maybe more specifically, where do we rank in terms of CO2 and other greenhouse gas emissions, per sector? How do we compare with other industries, and how does the U.S. specifically compare to other nations? Steve, you might be best equipped to kick that off, but Tom and Kevin, if you guys want to jump in. I think you're on mute, Steve. Sorry.
So happy to take an initial shot and let others pitch in. So aviation, based on most estimates and scientific work, aviation as a whole contributes to something like 2.5% of global anthropogenic greenhouse gases, and or CO2, I should say, specifically CO2. And there's been some other work done around other impacts of emissions from the aircraft that are non-CO2 or non-direct, that also have some greenhouse gas effects. And various studies have suggested that those might be as much as 2 times higher than the CO2 alone. So that's out there, and a lot of the NGOs focus on that, a total larger impact than just the 2.5% that people typically think about. So that's about 100 billion gallons of jet fuel consumption per year worldwide. The US's total consumption, all uses, military, commercial, business aviation, et cetera, in pre-COVID was around 27. So we're representing about 25-ish% of the impact worldwide from US activity, which is considerably higher on a proportional basis than some other countries. But given the size of our country and the economic activity, it's reasonable that that's the proportionate kind of impact that we have. And I'll stop there and let anyone else chime in.
Yeah, I don't have a whole lot to add to that. Steve is definitely more of an expert in this than I am. So I represent Aerospace, and we focus on electric aviation, but for smaller aircraft. Obviously, the large aircraft are where the majority of the big movement. I know we're, like Steve mentioned, 2 to 2.5, 3%-ish globally from a carbon perspective that's man-made or that's human made, I guess you could say. I think, Steve, we're somewhere around 12%, I think, as an overall transportation globally. If you look at all the transportation, I think aviation is anywhere between 12, 13%, something like that. I don't know what the future holds, but I've seen a lot of projections by 2050 that aviation will grow. Steve, do you know some of those numbers, those predictions?
Yeah, the thing that people quote a lot is the result of compound annual growth rates of CO2 increases. And historically, the industry has been growing on a CO2 basis or a fuel usage basis at somewhere around a 3% clip. And it's so if you take, a 3% compounded annual growth rate and scale it out to 2050, that's where you can get those 200 to 300% growth rates, depending on the exact level of growth that you assume. And that's what people like to quote, because then they're also making the premise that in that time frame from here to 2050, what you'll see is a lot of other sectors will continue to shrink because they have a lot of other sectors will shrink their emissions, perhaps because they have switching mechanisms that allow them to do that more readily than aviation does. So it's kind of an alarmist approach that people use to say, aviation emissions will be 300% of what they are today in 2050, because it infers a lot of assumptions on what happens and whether or not we have SAF uptake, et cetera. And then the other point that Tom mentioned, that's the other thing to keep in mind. It's the impact within the aviation sector. Like business aviation use worldwide only accounts for 2% of that 2.5%, right? And the predominant impact does come from larger commercial aviation. So it's also to keep that in mind when we're talking about different kinds of technology approaches that can potentially reduce greenhouse gas impact of aviation sectors.
Let me just sort of pivot off that question real quick and point this at Kevin. To piggyback on Steve's comments about projected growth. I mean, Kevin, sort of in a post-COVID industry, at least here in the United States, airlines have been radically changed by the pandemic. How comfortable are we, and Steve, of course, jump in, how comfortable are we that in the near to medium term that those forecasts will bear out?
So yeah, thanks, Jonathan, and great to be here. And we've already kicked off. At FAA, we can always geek out on the numbers, but so let me just start to kind of go back to that. There's a putting, context is really important. On the one hand, aviation is maybe a smaller slice of the global total, but on the other hand, if you break down the different sectors and look individually, they're all small slices, right? You need to make progress everywhere on this issue to really address it. Turning to the growth question, a couple of things. One is the track record is actually pretty good. If you look at US aviation emissions going back 30 years, they're relatively flat. In fact, from the early 2000s until 2019, before the pandemic, there's a significant growth in passenger numbers and sort of traffic in the system, but the actual emissions stayed flat. So what you saw is kind of a decoupling between growth in the aviation sector in the US and actual emissions. So that's a good thing. But looking forward, we've seen industry so far and the administration make really ambitious climate commitments. And for industry, A4A and others coming out with net zero by 2050, those are hugely ambitious. And then you have the forecast for continued growth out to 2050, which is pretty significant. We don't know certainly I don't think anyone has the crystal ball in terms of speed of recovery in the pandemic, although we're certainly seeing domestic activity ramp up pretty quickly. So that, to me, that therein lies the challenge, right? On the one hand, it's great that there are these very ambitious climate commitments. On the other hand, there is really sort of significant growth projected in terms of the next 30 years. So what matters then is the actions that both the governments and industry take to address this issue. particularly on sustainable fuels, but technology, operations, kind of the whole gamut.
So thank you to you all. I think that was really good to sort of kick off our panel and frame out what this industry's impacts are. I want to talk a little bit just for a few minutes about existing regulatory regimes. And there is truly enough here to have a webinar or 2 or 4 of their own. But I will tell you all, and in it all, sort of full disclosure, I am by no means an expert in terms of, what emissions regulations aircraft here in the US are subject to, and then when they fly overseas. So when a US registered aircraft operates overseas, what do they have to do to comport with EASA or some of the other regulatory agencies over there? Do we have anything comparable here in the United States, and what changes do you see on the horizon with the new administration? Is something new and something big coming in terms of regulation?
Well, I can start as the regulator in the room here. So I think the good news and the sort of positive story is that environmental standards are largely negotiated and developed internationally at the International Civil Aviation Organization. And that's incredibly important, right? Because as much as there's a large domestic market in the United States, operations around the world happen across borders, and sales of aircraft and et cetera happen, across borders as well. And so having a harmonized international approach is extremely critical. So there are 2 sort of key emission standards or policies in place that are relevant. One is the agreed internationally in 2016, a carbon dioxide standard, fuel efficiency standard for airplanes. We're in the middle of implementing that domestically here in the United States. The Environmental Protection Agency issued a final rule earlier this year, and the FAA will also implement that domestically so that US manufacturers can comply with the CO2 emission standards. There's also the International Carbon Offsetting Program agreed at ICAO, known as CORSIA. That applies to operators and requires them to buy emissions offsets above an agreed baseline to address their emissions. So those are kind of the 2 big policy regulatory measures in place. And I think there's certainly, in terms of the US government, I think we're in the early stages of identifying both kind of what the big picture vision is on aviation and what specifically we might do in the space of policy or standards beyond what's currently out there.
Kevin, I'm going to ask a quick follow-up specifically the carbon dioxide framework that you mentioned. And this is certainly, by no means an apples to apples comparison, but for folks like me, and I assume some of our viewers that are not experts in all things emissions, I am assuming that it is somewhat akin to the CAFE standards, right? And that the emission standard is not just a point in time, but that there is, there are, I would assume, gradually trending improvements or requirements that OEMs must meet for emissions over time. Is that right?
Actually, no. It is a little different and not quite as mature. But so to start, it's similar to, yes, in concept, kind of a miles per gallon for a car. This is a fuel efficiency metric for aircraft, right? But this was the first ever sort of adoption of that back in 2016 and done internationally. So it is actually sort of a single standard that was applied based on the information then. And if it's going to be updated, then the International Civil Aviation Organization needs to come back together and look at how to update it. And one thing, obviously, that's really different with aviation than ground transportation is the amount of investment, the lifespan of these vehicles, the time it takes to involve, and you know, last but not least, probably most important, the safety requirements needed as new standards are put in place. So there's a lot of factors that go into determining the right standard level. And the last thing I'll say is just, you know, the push and pull on this then is that there are some that believe ICAO is not acting fast enough, or that the standards are not ambitious enough. But really, it's a complex set of trade-offs that need to be made to develop and set the standard.
Okay, good. That's helpful. Tom, I want to bring you in to talk about electrified aviation. We've talked now about you know, power sources or power plants that emit. You know, the technology that by Aerospace and some of your competitors, I don't know whether you would view them as competitors or not, but some of your you know, your contemporaries in the market are pursuing all electric aviation. You're just you know, one of a few handful of other promising players out there. Let me first ask you, you know, maybe tell us a little bit about where BAE is specifically in terms of development and going to market. How has it been working with the FAA to certify or during the certification process? And then I've got a couple of follow-up questions for you.
Yeah, you mentioned talking about you know, webinars and enough material to cover. We could spend a long time discussing the interaction we've had with the FAA. It's been very good. We've got a great team at Aerospace that has certified several aircraft at different levels across the industry, and now they work for us. So great connection. It's been a great working relationship, and I would say, you know, from a certification perspective, we put our application in 2018, and you know, we're really the first to go through what is the FAR Part 23 Amendment 64, which at the time was a rewrite. First to go through that certification process for electric aviation, and so yeah, I can't get into all the milestones just because of some sensitivities, but I mean, essentially, we are well on track for certification. We're hoping to be certified by the end of 2022. You know, it's been great working with them all throughout the full airplane design. Obviously, you know, you're taking an internal combustion engine that we have a great certification basis for, and adding electric, and everything from fuel storage versus electric battery storage. You know, I don't know if we want to bore down into the details, but it's been a great working relationship. I think what it would be helpful maybe is to talk a little bit about what is out there today for electric aviation and what type of airplanes we're talking about. So specifically, there are airplanes that are being sold that are LSAs, light sport aircraft. You know, under EASA regulations, Pipistrel is selling an airplane that is roughly 600 kilograms. So I think it has to maintain under a certain weight class for LSA. I'm not an expert there. But what we're doing is going through the full certification pathway. So the motor will be certified. We'll have a FAR Part 33 certification. It'll have an EASA Part 33 certification. The batteries will have a certification, and the airframe itself, the overall airplane, will be certified under FAR Part 23. And we believe we'll be the first to certify, but there's a whole list of companies behind us that are certifying different platforms. We're starting with a 2-seat electric airplane for purpose-built for pilot training. So when we talked about, you know, the global carbon emissions and all the other emissions that Steve was referring to, we're a little tiny component of that to start with. We're talking about pilot training, and you know, we think we can remove about 5 million metric tons of carbon a year, 900 plus million metric tons. So 5 divided by 90 is roughly, you know, the percentage we start with, but it's the pathway. And in addition to carbon reduction, we're eliminating the use of leaded fuel, obviously in general aviation, 4-seat airplanes, piston engines. Typically, there's diesel versions, but there's also, you know, the majority of it use 100 low lead. So removing the lead emissions is a big deal. Kind of back to you, Jonathan. I'm sure you want to kind of focus me here.
Yeah, no, that's really good. And I'm going to ask you I'm going to ask you a devil's advocate question that I think, Steve, if you don't want to jump in now, we'll have this conversation maybe a little bit later on as it pertains to the life cycle GHG impact of SAF. But Tom, let me ask you, I mean, talk about the value proposition of electrifying aviation at your scale, right?
Absolutely. Yeah.
Flight training. What is the value proposition there?
Yeah. So we believe, and again, everything, electric motors are 95 to 98% efficient, very efficient. And ultimately, we as an industry want to be energy storage agnostic. So you've got fuel, obviously, oil, right? You've got hydrogen that people have been talking about. You've got solid state battery or lithium ion batteries, and then all sorts of forms of that. We want to take, and as Wayne Gretzky always said, we want to skate to where the puck will be, not where the puck is today. So as we design the airplanes, we're designing it today with batteries that are on the Tesla Model S, that are that are being used in industry that have high commercialization capability, and we can close on pilot training business cases. So the airplanes that are used just to build hours for these airline pilots. We believe the ceiling for us with the lithium ion type batteries, whether it's lithium sulfur, lithium metal, solid state, is probably 500 nautical miles and less, right? So regional travel, Part 135, 91 fractional business type stuff, cargo, feeder fleet type operations, smaller regional, up to about a 19-seater. We don't think going beyond that is really feasible under the kind of lithium battery regime. Like, we still have a long ways to go to get to a 19-seater, 500 nautical mile. We think by the end of the decade that's capable, but your real core business of 2-seat, 4-seat, 8-seat type airplanes, it's 1/5 the operating cost. So when you look at the variable operating cost, you have a lot less wear and tear on the airframe. There's one moving part in the motor versus 900 parts in the engine. So from a utilization, from just a maintenance overhaul, it's cheaper. Electric grid energy, for us at the 2-seat pilot training, it's about $23 an hour to operate versus, a Cessna 172 is anywhere between 100 to 120, depending on where you're buying fuel. Same thing energy wise, electricity is $4 as an hour versus probably about $50 an hour. So there's a huge differentiation for operating costs. But again, these are smaller airplanes. We're not talking about 737s. We're talking about smaller airplanes. Zero emissions, better performance. So just like a Tesla on the road, if you pull up next to it in your BMW 3 Series, it's going to kill you off the line, right? There's no doubt about it. 2.5, 2.6 seconds off the line. First, 0 to 60. We do the same thing. We can climb faster. We just don't have the range. We could beat a typical traditional airplane on every metric except for range. But we aren't going after, LA to New York. We're going after the pilot training market. Safer operations, no post-crash fire, right? So these batteries have to go through full thermal runaway analysis, understanding how you capture that. So in the event that there's a hard landing, there isn't I broke my back, but I can't get out of the airplane in time fire. There's no combustion in the wings or overhead if it's a 172. Longer operational life, right? Higher utilization, and then less noise. So again, we're not trying to replace a 737, but this is a pathway to show how could you do regional operations. So those are the kind of the initial advantages of electric aviation.
So before we move back to SAF, a couple of questions for Kevin and Steve on things like life cycle GHG. I've got to ask you, is electrified aviation simply moving the emissions upstream? The power's got to come from somewhere. If it's not produced by solar, if it's not produced by nuclear, are you just moving your emissions out of the tailpipe of the aircraft and into a smokestack somewhere else?
So I'll just say, I think that's a good question. Although we tend to think of it, we tend to think at FAA not just of combustion emissions, right? When we think about it as energy. So it is, and I appreciate kind of Tom's remarks there, and I think it's really important the work that his company is doing and others on electric aviation for GA, not the least of which is leaded avgas, which he mentioned, right? That's a huge impact. And so it's something to consider. But we would look at it as a life cycle emissions question, because right now you're seeing a lot of activity with drones for package delivery, advanced air mobility concepts. All those have a lot of potential, but anybody who says there's zero emissions is not really telling the full story, right? And so when we look at it as a regulator, and as we think about policy and how the policies we fit with the administration's climate ambition, we need to look at the whole system. So is a new segment, whether it's electric vehicles, for small aircraft or advanced air mobility or drones, what's the net environmental cost there?
Yeah.
And that's the way we're going to look at those issues. So they really do have a lot of environmental potential, but it's important to look at the full life cycle.
Tom, you want to jump in?
Yeah, I do there's a couple things to think about from an infrastructure. And I know we can talk about this more and on the larger scale, Steve can really help here, but let's just do a thought experiment. So I'm at Centennial Airport, one of the busiest GA and business airports in the country. And in fact, for anybody that's following aviation, this is where the Key Lime Metro airline jet, little twin airplane, not twin, but it's like a 19-seater, collided with this Cirrus SR-22 a couple weeks ago. This is our airport here. So if we were to get to the point where we could do like a King Air 250 equivalent of electric, a PC-12 NG for anybody that kind of follows aviation. So, an 8-seat type airplane, twin, single, turboprop airplane. We go from today, we need maybe 2 megawatt hours of energy at the airport, just kind of generically speaking. When we need to go charge those airplanes, let's say we do 100 PC-12 converts to all electric, just, our airplane in place of a PC-12. Let's say we charge 100 of them a day, just for whatever the mission might be, just very generically. We're going to need about 50 megawatt hours of energy that we didn't have before. So right now, what you see across the grid, this is more of a energy question, a grid question, not really focused on aviation, but it pertains to us because we have fixed airports all across the country. The nodes for the grid can't handle all that electricity. There's plenty of electricity on the grid. It's the actual node, it's the circuit coming into the airport. We have brownouts here sometimes in the summertime, right? And so rolling brownouts. How do we handle it when we need all this? So there's got to be a very distributed energy resource focus around solar at the airport with storage and grid, like grid management and thoughtfulness around that. So it's, your energy is only as clean as what you're coming off the grid. So if it's coal, it's not going to be very clean. But if you're in the East, or if you're in Washington State, it's all hydro. If you're, in Texas, you've got solar, you've got wind. There's all sorts of solar's the cheapest by far, but it's just a matter of there's more infrastructure. So we can't do this tomorrow. This is just a long, thoughtful approach to it. Hopefully that kind of helps bound, the energy question. If we were talking about DIA, we'd be talking about, 5-6 gigawatt hours extra we need a day. But again, we can't transition a 737 to electric anytime soon. It's going to be a while.
Yeah, Tom, I think that's a good point. And actually, I'm gonna loop back with you and with Kevin at the last question or prompt in our discussion about that thing that you mentioned about nodes. What can the nodes handle? The need for grid infrastructure at the end of the node at airports. But I want to turn, Steve, you're unmuted. Did you want to jump in, or otherwise I've got another sort of prompt to jump off on SAF.
Yeah, I was just expecting you to come my direction. Go ahead.
Yeah. Well, I think before I go to you, Kevin sent a chat and said, he said, Tom, where can I buy one of your aircraft? I want to know, Tom, when can we buy one of your aircraft?
Yeah, we're working hard. It's definitely a process. We were hoping to be certified at the beginning of 2022. COVID definitely had a somewhat delay for us, so some months of delay, but we are on track for late 2022. There's certain things that are going to keep that or push that, and there's some. Again, we're working with the FAA on the motor. So the motor certification component is a big deal because it locks down our design, and
Sure.
so we're working through that right now. So. Hopefully we'll start delivering airplanes at the very end of 2022. That is our plan. We haven't announced anything yet, but we've already picked our production site. We're going to be building that out and scaling from there. So
great. Steve, I do want to turn to you, and I'm going to sort of flip flop the order in which I was going to ask these. Talk to us about the progress to date on SAF. I think Tom's done a really good job of framing out the fact that we can't and we won't electrify 737s tomorrow, or probably in any of our lifetimes. But talk to us about SAF as the most promising here today, move away from GHG or move to GHG reductions in the industry. Who's using it? Where is it? How much is being consumed? And what's the demand?
Okay, broad question. Demand is large, and I don't know any better way to say that, because you see various entities, including the Airlines for America companies, 10 major carriers in North America, have made commitments to net zero carbon by 2050. And a couple of those airlines have actually even gone more aggressive than that and have talked about net zero carbon in 2040. And yes, if you look at the whole spectrum of options that an airline has to reduce its emissions or improve its efficiency, it's through operations, infrastructure, incorporation of technology, which includes SAF. And the level of inefficiency in operations and infrastructure is not huge. So even if we solve those completely, got it 100% efficient in our operations, the continued growth of the industry driven by demand, creates this profile that we're trying to abate. And so, yes, absolutely. Over the next couple of decades, SAF is going to be the predominant mechanism to actually bend over our growth curve and start on a trajectory towards long-term reductions.
That's helpful, Steve. Yeah, no. I in fact, I was going to pivot to Kevin and just talk about the FAA's role in approving the use of SAF. And I think, Steve, you would agree. I mean, where SAF is an available drop-in alternative. It's I don't think it's ever neat. It's almost always blended. But Kevin, can you tell us about what the FAA's role as the regulator is in making sure that something that goes into an aircraft is safe?
Yeah, no, great question. I mean, actually, so fuel to be safe actually meets a third-party specification that's done by ASTM International, right? So there is this is a consensus-based process to establish safe fuels. And this is something, frankly, this is getting back to why it's important to have a strategy and kind of take going back to the old Wayne Gretzky line, right? We've been working on sustainable aviation fuels for years now, and really focused on not just the sustainable piece, but also the safety piece. And there's 7 feedstock pathways that have been approved. FAA's played a leadership role, but it's not FAA alone. It's working with industry, and we've gotten better at it over time. In the beginning, we were using really large quantities, volumes of fuel just to do the testing. We've actually improved our ability to do the testing with less fuel and shorter period of time. So, many years of work to get to a point now where we have safe and reliable fuels. There is a blend limit at 50%, but frankly, that's not something to be concerned about in the near term, given the volumes of fuel there are and the demand. But it's something we're working on to go to 100%. And then there's making sure that the fuel meet rigorous life cycle emissions reductions requirements. And we've been working internationally at the International Civil Aviation Organization to set and adopt sustainability criteria for these fuels. So there's a lot of work that FAA has done really in collaboration with other agencies and partners in the private sector through the Commercial Aviation Alternative Fuels Initiative. So it's been a team effort, and I think, but that sort of attention and focus has really gotten us to this point where we see the production volume scaling up, and this see SAF as really being one of the bigger solutions for aviation's climate impact in the next 15 to 30 years.
Kevin, I want to stay with you for a moment. This is a question that I had originally intended to direct at Steve, but Steve, I'd invite you to jump in. At a Politico event a few months ago, Scott Kirby had some critical words about carbon offsetting programs, and I think pledged that his airline would get to their net zero goal without carbon offsetting. Steve did a really good job outlining where the potential bottlenecks are in SAF, right? It's the industry's growth, it's potentially the infrastructure. We can produce more of it, but as the industry continues to grow, what does that mean for the production versus demand? Can you talk about the carbon offsetting program that you previously mentioned at ICAO? And then Steve, maybe you can jump in and tell us what the airlines and the industry are doing in the interim. If they can't run 100% SAF all the time, what other activities are they undertaking to meet their emissions reductions goals?
Yeah, I'll start. I think it's a really good question. And, I think as we see, number one, great respect for all that United's done in this space, including on sustainable aviation fuels as a leader in that area. On the other hand, things like criticism of offsets, seems to be more posturing rather than sort of kind of meaningfully getting at the issue, right? Again, the way we look at how we solve this problem is, what are the levers that you can pull to reduce emissions from aviation? You can introduce new technology. You can introduce sustainable aviation fuels, look at different energy sources. You can fly more efficiently. You can put in place policy measures, taxes, et cetera. You can fly less. Those are the things you can do. So if the aviation sector is saying we're going to meet net zero in 2050, they're either going to do it through those things, or they're going to be still a net source of emissions and need to go to other sectors. Even if you don't call them offsets, if they're not coming from aviation, they're coming from somewhere else. So, at the end of the day, aviation's a source or a sink for carbon. And so the goal is to make it as small of a source as possible. I would say that most experts probably believe that by 2050, aviation will still be a net source of emissions. So, the question in my mind is, where is that gap? Where's that sink going to be to offset the emissions? So whether someone, is pejorative about offsets, the reality is it comes down to where you're going to get your emissions reductions from.
So, Kevin, that's a really good question. And Steve, I guess I'd be curious to know if you agree with Kevin's assessment that in 2050, aviation may still be an emitter, but could you also maybe just round out this part of the discussion on that gap that Kevin mentioned? So if it's not true emissions reductions via SAF, what else is it?
Yeah, no, I agree with everything Kevin said, and it's been a long-standing overall commitment and architecture that the aviation industry has sewn together here to address these issues, both with respect to carbon neutral growth from 2020 and long-term commitments. So here's the fundamental challenge, right? The fundamental challenge is that fuel consumption represents a large fraction of the operating cost of an airline. And the production of sustainable aviation fuels today is significantly more expensive than it is for the production of petroleum-based jet fuel. So it's a conundrum. The conundrum for each airline is to decide, okay, we know that there are some advanced technologies out there that perhaps continue to lower the price point of these fuels. We know, based on societal demands, that we're probably going to see something with respect to carbon taxation or some impact on, the price value of the carbon proposition. And so hopefully at some point, the production of SAF, the cost of SAF crosses over the cost, or I should say price in both those cases, potentially crosses over the price of petroleum-based jet fuel. And when that happens, obviously, you're going to see significant real demand, a real incentivization for involvement in incremental SAF production from the airlines. Until that happens, it's really up to each airline to make a decision on how they want to participate in this catch-22 kind of scenario of, okay, we got the technology that's out there that looks promising, but how can we start this cycle today? We believe that the industry can start to reduce costs by coming down a learning curve. How can you come down a learning curve? By actually putting production in place. And it's painful to put that production in place because the price is high. So what you find is airlines around the world taking slightly different approaches on how to tackle that issue, right? How can I make some strategic investments in these firms? How can I be involved in technology development and supply chain development? And then how much fuel am I actually willing to take on to start down this, learning curve process? The good news is that's all happening. It's likely not as fast as any of us would prefer, but it's a huge challenge, right? So then what comes into play? What comes into play then is that, the standard purpose of policy is policy addresses shortcomings from a free market perspective. That's what we have today, a societal expectation of reducing CO2, but not being supported by free market economics. So policy comes into play. And it's come into play in the form of a federal approach on a clean fuel standard or renewable fuel standard, in terms of tax policy at a federal level, in terms of state incentives from a low carbon fuel standard perspective, as well as at the international level, the policy associated with CORSIA. Those things also come into play and start to close, or even, more than close, the potential price gap. That's on an incentive side. We're also seeing from a regulatory perspective, the stick approach, not the carrot approach, but
right.
The concept of blending mandates, of forcing a certain percentage of all jet fuel production to come from renewable sources. That's an effective approach, but it sort of runs roughshod over free market economics, and you need to be careful about exactly how those kinds of approaches work, for fear of creating bias in the marketplace for long periods of time with respect to the purchase of SAF. So there's a full range of things that are going on, a lot of moving parts, as Kevin mentioned before, with respect to helping close that price gap, at which point these fuels take off. From CAFE perspective, we've just been working on fundamentals, as Kevin mentioned, from 2006, 15 years, working on the fundamentals of making more and more technologies applicable for the production of fuel, looking at spaces in the supply chain, feedstocks, et cetera. And so going forward, we're going to have a large focus on use of waste streams for feedstock purposes, because those tend to be lower cost than purpose-grown feedstocks.
Sure.
We don't yet have the right technology suite for all of those sort of ubiquitous kinds of feedstocks. And so all of that stuff is in development. So across the board, we have airlines involved. I hope to continue to maintain that momentum as different airlines continue to make more aggressive commitments to meet these societal demands. I expect more of them to step into this space, have additional offtake agreements, additional investment, collaboration with the government on research, et cetera.
That's great, Steve. Thank you, and a really good overview. I think about of that gap and where we are in the interim. We're right up at our time. We have 1 minute left. I'm going to sort of break my own rule and just ask one last question to Kevin and Tom. As I sort of promised, I'd circle back to this. Couple of programs that the FAA runs near and dear to my heart, since I may or may not have had a hand in changing some of them in the last FAA reauthorization on behalf of my former boss, a member of Congress on the aviation subcommittee. But when we sort of envisioned this panel, we thought about it, from the sort of sustainability writ large, not just electrification, not just SAF, but what else are the regulators doing? The FAA runs the voluntary airport low emissions program and the zero emission vehicles program. Kevin, can you tell us just a little bit about those programs, or if you want to choose one or the other, can you give us an idea about past projects? Is the program more workable now than it had been in the past? And Tom, if you want to jump in, I think this is potentially an interesting discussion with the regulator to say, hey, are these programs, are Vail and Zeb a potential avenue for infrastructure development or improvement that's needed for electrified aviation charging?
Okay, well, in general, these topics are outside my expertise, but I'll say, and I'll focus on the Vail program, which is really been a program to provide lower emitting equipment for airports. And that program continues to be pretty active, but there are limitations that even with the last reauthorization, limit its overall ability to be utilized to do things like electrification of ground support equipment, et cetera. So, but the current administration is really focused on how to use the existing programs as they are to leverage them to reduce emissions at the airport. But I know there's also a lot of discussions going on right now about ways those programs might be further tweaked to make them sort of even a better fit for things going forward. But that's about all I have to add on that. Thank you.
No, that's good, and I think that's good insight from a administration perspective. They would sort of, as I think other administrations would, maybe of even different political affiliations, would prefer to not go whole cloth on something and try to make their policy agenda fit into the art of the possible, as opposed to having to go to Congress and ask for a change. Tom, you had mentioned that potential pitfall with the nodes at the end of the grid, right? What is it that airports and the industry needs in order to make electrified aviation truly viable at airports across the country, at different a diverse geographic network of airports, and not just a few airports in California?
Sure, absolutely. It's a lot to unwrap here, and I know we don't have time for it, so I'll just say this. FAA can be a huge supporter of what we're trying to do. They can be very helpful. We can find the right efficiency and use of the current programs. But honestly, if we look at the big picture, we just want to make sure aviation across the board is not precluded from any of the infrastructure programs that the Biden administration is pushing and that Congress will vote on later this year. That's the simplest way to put it, that we want to make sure when electric buses, cars, all the different infrastructure going into place, that the FAA and aviation in general has a place at the table. We don't need a very big place at the table because we're small in comparison to the grand scheme of mobility. But as we grow, we definitely want to make sure that we have the resources to connect the airports across the country as we grow.
That's a really good point, Tom. Thank you. And that is really our time. We had one question come in that, Kevin, you might want to, and actually, Steve, I might invite your opinion on. How does the U.S. compare to other countries in terms of adopting or implementing our emission standards? Would you consider us to be a leader or a follower?
Sure. Just quickly, again, the goal is actually an international process. Over years, it's the FAA and the U.S. government has been a leader in those. Initially, it was bringing U.S. environmental standards to the international forum to have those adopted. And then more recently, it's starting internationally, but we bring a lot of the analytical and technical resources to that forum to actually develop standards and adopt them. And of course, the political will as well. So the U.S. is very much a leader there. And then, of course, implementation can be challenging, but again, we are also kind of lead and implement those rules as efficiently as we can.
Okay, we are past our time now. Thanks to you guys for your patience. It was a great webinar. I want to thank those of us, those who are attending with us live, and the many more that we know tend to tune in post-event when we post this on our social media channels. So thanks again, Tom, Kevin, Steve, to my colleagues at the Aero Club Runway Program, Callie and Sierra. We appreciate you all being here, and look forward to the next program that we have through the Aero Club's Runway Program. So thank you.
Thank you
Thanks,
very
Jonathan.
much.
Appreciate it.